Good morning, afternoon, or evening. Physics, this will be the beginnings of Unit 3, the Fields Unit. Okay, so hopefully you finished up Unit 2, Conservation Unit. Did your quiz maybe you're waiting for a little bit to do that yet. Maybe did your hand in. Okay, so today we're going to look at the Fields Unit. Okay, 2 more units left in the course. Of course, it's shorter, first one being long, and the second being about a medium-sized one. So these ones will be able to finish up fairly quickly. Let's get this down here, move this over here. Okay, Blackboard's popping open here. And what we'll do today is we'll just basically look at what we're going to do in the unit and then start out with some diagrams with some basic electrostatics that we have that we're going to be doing here. As soon as this thing pops open, there we go. Okay, so today is the first unit of Unit 3. So let's get that set up here. There we are. Okay, Unit 3 today. This is in physics. This will be day 1. Okay, so first thing I want to do is I want to just outline the unit a little bit, what we're going to do. And then we're going to be looking at electrostatics, the laws of electrostatics. And we're going to be looking at drawing some point charge diagrams. That's probably all we'll do today for the first day in the unit. Okay, this unit should take us, about 13 or so, 14 lessons or so with some assignments in there for a couple of lessons. I'm gonna cut this into 2 parts: magnetism and electricity, which basically is similar because wherever you have magnetism, flowing electrons exist. Wherever you have flowing electrons, magnetism exists. They're similar, but have different properties in them. So I'll split them into 2 smaller assignments. We won't, kind of like we did in the first unit where we had 3. It was a longer unit, but this one will be split into 2. And also we'll have 1 quiz in this unit. So let's go through kind of what the Unit 3 topic outline, I guess. Okay, so we are going to look at electric fields first. It is a field unit. Okay, back in the day, before they changed the physics curriculum a couple years back, actually this is the second year I'm doing it, so it would have been only a year back. It was the first time I did it. We used to do a lot of electric circuits. Okay, now we kind of do electric fields, and part of that area we do more of the basic electric fields and Coulomb's law and things like that. When we do less electronics type stuff, so we don't have any of that stuff in here anymore. But we might touch on it if time permits. So in electric fields, we're going to look at the basics of electric statics. So that's what we're going to do basically today. We're going to look at charge transfer and the rule for charging. Objects. Okay, we're also going to look at Coulomb's law, so we'll have some calculations as well in here. And we'll be looking at electric field generation as well, where we want to get to in the end. Oops, spell that right. Okay, so that's the first part. And then we'll have a little assignment in finishing up this section. Right in here. Okay, it won't be it'll be kind of like the vector assignment, nice quick short one out of 20 marks or something like that. 5, 6, 7 questions, somewhere in there, just on that area. Then we'll get into the magnetism and its field. So the magnetism part of this course, there's actually 3 parts to this course. I said 2, but there's actually 3 in this. There's also gravitational as well. Okay, and we're going to be looking at, when we get into magnetism, there's a couple of things that we look at there. We look at the current and magnetism. We'll say magnetic field because that's what it produces. Okay, we'll also look here at as well EMF, electromotive force. We're also going to look at the right-hand rule and the motor principle. Well, actually, there's some right-hand rules and the motor principle, how that works with flowing current. Okay, and that is it for the magnetism part, I think, if I remember correctly. And then we get into gravitation. We don't have an assignment there. We'll stick it at the end. I think we kind of look at gravitational fields and electric fields. We'll put that assignment together if I remember how I did it last year. So this will be the third part of fields, gravitational fields, and we look at Newton's law. We already looked at Newton's law, so we don't look at that, but we look at Newton's law of universal gravitation. And the universal gravitational law, if we look at gravity and the theory of relativity. So like at the end of this, we kind of get into our last unit being modern physics, which talks about theory of relativity and things like that. So then we'll get into that. So I think before we do that, we'll do gravitational fields. People want to do that, I don't know. Gravitational fields, we'll look at gravity and the general theory of relativity as well, planetary motion. Okay, gravity is important in the theory of relativity. I'm not sure if we're looking at general relativity. Might be a little bit too much mathematical for us, but we might look at special relativity, or at least we'll look at the theory behind it. The math part of that is quite deep. You need some more instruction in math to do that. So that would be basically where we go to, and then we'll kind of throw the second assignment in there. And then we'll have our quiz. So the first unit we had 3 assignments. Second unit we had 1. Third unit we'll have 2. Fourth unit we'll probably just have 1. Fourth unit will be our shortest unit. Sorry, guys. Okay, let's go ahead. That's kind of what we're going to look at today. So today we're going to focus on basically this here basic electrostatics to start with. So let's get that on the next page here. Okay. So we're going to look at electrostatics today. Okay. And we're going to look at that basic electrostatics today, and that's what our goal is going to be. So let me just pop open my background here a little bit. Now you should have some background in looking at the laws of electric charge. Okay. Back in the day when Ben Franklin first worked on this area, he not first worked on it, but when he worked on the area, he assumed that the positive charges moved, which we know is that electrons are the ones that move now. And so we're going to be looking at that from that point of view. Conventional current, okay, if you know, is with the moving positives. Electron flow current is with moving negatives. We're going to still use conventional current whenever we do the right-hand rule. We won't be doing the left-hand rule and things like that. That's for moving electrons. And that's great when you use that for, when you use left-hand rule and all that for moving electrons. But that's not what happens if one of you guys graduates and goes into the electric field. Everything is done with the assumption that the positives are moving, even though that's against theory because of what Ben Franklin did. So what we do when I teach it is I teach it that way so that if you go into the electronics field, you don't have to switch poles around or anything like that. So that's what I'm going to do here. But you should be able to understand that both can be done. Okay, so let's get started on electrostatics part. So the first thing is that we know with electrostatics, there's a couple of tenets in here. So the first one is that electrons move. Okay, even though we'll be talking about conventional current mostly when we get to the current part. So electrons move. Okay, they're the moving ones. Protons and they're negative charged, I guess. So they have that negative charge. And there is a base charge, which we'll talk about when we get to the math part, for each electron. Okay, neutral objects have no charge. And also they are have equal numbers of protons and electrons. The protons are the positive charges. And electrons. Okay, and we also know that objects with like charges repel each other. Okay, repel each other. And that's electrostatic force. Stated there. Okay, the opposite is true as well. Objects of opposite charge attract each other. And again, you're using electrostatic force. And highly charged objects can attract neutral objects, depending, and they can separate charge. Okay. So these are called the laws of electrostatics. Okay, so we're going to look at point charges and draw 5-6 diagrams about point charges today and how they create some electric fields around these point charges. Okay, and then we're going to get into Coulomb's law. Probably won't get that far today, but we'll get into some of these diagrams that we have. Okay, because we're only about 15 minutes in. I want to keep it in that 35-minute range, 40-minute range today. So keep it that way. So what we want to look at today is we want to look at some diagrams of point charges we'll start with. So if we have, let's get our marker out here. Let's say we have two opposite charges. So they attract each other. So if we have that in our case, and what we usually use, I'll use the proper symbols in here. Okay. Okay, so let's get ourselves a little skinnier than that. There we go. Okay, so let's say we have a point charge. So we're going to use plus there, and we'll use a minus here. Okay, these are the 2 point charges. And if we're looking at these charges, we'll call this one Q1, and this one Q2. Okay, Q equals the charge. Okay, and charge is measured in coulombs, named after Coulomb. Okay, that's the unit of charge. And if we have some distance in between there, between the charge, whatever it might be, there's a distance in there. Okay, and when we get into coulombs, the size of each charge plus the distance away from each other will affect the force on it. So now it says that opposites attract. So what we're going to see here is we're going to see that this one is going to have a force, okay? And if we're doing opposites attract, okay, they're going to have a force that is pulling them together. Okay, so if we have this force, okay, and this force that are causing them to move together. Now this is the force of object. This line here, the positive is causing this attraction line. Okay, so this one here, if we're labeling it correctly, this one's going to be the force of object 1 on 2. Okay, so this object 1, charge 1 on 2 is this line right here, causing it to attract to it. And this one here, this is the force of 2 on 1. Okay, so that means that we have that attraction in the middle. So this one here is actually this force of this one pulling this one closer, and this force here is the actual force of this one pulling this one closer. So they're going to come together. Okay, the opposite is true if we have like charges, pardon me. Okay, so this is opposite charges in here. We'll put it right here. Okay, so that's where they're attracting each other. And if we do like charges underneath, the exact opposite happens. Okay, so let's just make a little more space here and draw that. Okay, so if we have like charges, so two positive charges, okay, this time we have, we'll say this is still Q1. Maybe I should have said QA and QB, but Q1 and Q2. We still have that distance in between, whatever it might be. Okay, but this time, this object pushes on this object away from it. So we have, if we draw our arrows, okay, we have this force going this way here, and this force going this way here. So this is the force of, well, if we call this one 2, this is the force of, let's get my marker out here. Okay, so this is the force of charge 2 on 1, and this is the force of charge 1 on 2. So it's the same force, but they're now in the opposite direction. So this one's putting a force on this one, and this one's putting a force on this one, and now they're pushing away from each other. So that's kind of how the laws of attraction and the law of repulsion works with electrostatics, right? Okay, and highly charged objects can attract neutral objects, and we'll talk about that later on here. Okay. So now the last thing we want to do today is we want to kind of go through a couple diagrams of electric fields that can be created between 2-point charges. Okay, so we're going to be looking at 2-point charges and how electric fields can be created between them, rather than just the force that you see right along the linear line, the flat linear line. Okay, so if we had a positive charge, if we have a point charge electric fields, we'll start with that. I keep on doing that wrong. What is it? IE? Yeah. I always spell that wrong. Where's fields here? Okay. So let's get that right. There we go. Okay, electric fields around a point charge, meaning there's just a single charge. So if we have a positive, let's move that up so we can see a little bit better. If we have a positive charge, like, use this black again. Give yourself some space. And if we have a negative charge, okay, the electric field's lines are vectors. So use an arrowhead. Okay, and if we have a positive charge throws out in around it repulsion charges here like this around a point charge if there's nothing else around it. Okay, and then the opposite is true about a negative charge. If you just have 2-point charges like that. So that this is the electric field around it. This is the electric field around a positive charge. Okay, and that's what this blue stuff is. I should probably label that. And this represents, the electric field lines represents the force around them. So now if we draw the electric field kind of around 2-point charges of like charge and of opposite charge, it's going to look very similar to the magnetic fields, if you remember from way back in the day. So there's just if you have the 2 points by itself. But if we do the 2-point charges, sorry, let me just set up my background here. There we go. Okay, so we'll do 2 opposite charges together. Okay. First, let's do this on the next page though, so we can draw it better. Okay, so a diagram of 2 opposite charges. We'll type this out in nice typing here. Okay, electric field around 2 opposite charges. So we'll say 2 opposite point charges. Okay, and it's much like your electric field. So let's do black again for the point charges here. So let's put the positive here and let's put the negative back here. Okay, so the field lines, we'll get out our arrow here. We're going to change them color. Okay, so this is going to go from positive to negative right along the middle. Should have had that down a little bit. Okay, and then as you go out, they're going to kind of bend, so we have to kind of draw these with the curve like this. Okay, and it's going to go this way, like that. Okay, and the same thing happens here. Okay, try to make it symmetrical looking. Freehanding it, that's not quite symmetrical. It's going into the negative charge. Okay, if I go out a little bit farther, it kind of bends even more like this. Okay, and same thing here. Okay, so we have that's kind of like the inside. Okay, and even if you go out even more, kind of like say up at the top here, we kind of bend, it goes out straight and then kind of bends around. Like this. Okay. These one little bit more space in between each of these usually. Okay, this one too. Okay, and it kind of does that turning in like that as well. Okay. And if you go kind of way out, you'd have kind of lines coming in like this one and this one. If it went way out like that, and this one here would also have lines going out like this. If it kept going around like that. So that's kind of what an electric field charge looks like when we have 2 opposite charges, okay, going from the positive, pointing in towards the negative for the force out of this one. Of course, this one, if it was putting a force on that one, it would be pulling itself towards it as well. Okay, so that's how it works. Okay, this one is also going to be pulling it towards it as well. But that's generally how we draw that. Now, if we have two like charges, two like positive charges, we'll stick with positive charges. We'll draw the electric field line type diagram as well. So these ones are going to have what we're going to have that repulsion that happens. Okay, so let's do this diagram. Let's check our time here. See how we're doing. Okay, well, so this might be the last thing we do today. Yeah, probably, because it's 30 minutes. Okay, so let's do one more here. Underneath, we'll go the electric field around two like positive charges. So if we do two, let's give ourselves a little more space here. Okay, this one here, again, we're going to have our positive charges. Okay, and they're going to repel each other this time. So what we have here is we have this force coming out, and then it kind of bends upwards like this. Oh, I should have done different colors. Sorry, let me do that. Okay, let's go back to our original color, blue, I think we were using. Okay, so it kind of comes out and it repels like this. Okay, and this one as well. Okay, maybe a little more symmetrical than what I've got here. Not as much angle as the last one. When you get out like this, kind of. Okay, they're showing a repulsion between two. Okay, and then over here on this far side, these just go out and away like this. These ones kind of look the same. Okay, so they're repelling each other, those two positive charges, when you try to push them together. So you're getting this kind of an electric field in between the two, and out here we have that kind of electric field. So those are electric field lines again. Okay, and the more electric field lines there are, the stronger the force that's created. Okay, per area, of course. So we'll just make a note of that underneath each of these diagrams. The more electric field lines, per area, the stronger force in that area. Okay. Repulsion or attraction. Okay, so that gives us the positive charges there. We've got the opposite charges as well. I think we'll stop there today as we're right rolling into about 36 minutes now. Okay, so that's the beginnings of the electric fields unit. What we'll do probably next day, if I take a look here in day 2, we'll probably get into, let's see, where are we here? Let's see. Okay, so yes, we'll probably get into Coulomb's law and talk about measurements of coulombs and what they are, and look at some induction and charging by induction, charging by contact, charging different objects, talking about the basic charge on a electron and things like that. So that's what we'll do next day, but we'll stop there. So we'll see you tomorrow.